All right. Okay. Here we go. We're going to talk about some stem and leaf displays. Again, this will be something that if you do the activity for chapters 4 and 5, they will come back. So don't forget how to do them because they will come back. All right, we're going to learn how to construct a stem and leaf display from raw data. We're going to be able to visualize the distribution and compare stem and leaf plots to histograms. It is, I think, kind of cool to see that. All right. You guys can take a minute and read that if you would like. Not really sure why they feel it's super important to have, but hey, whatever. I don't judge. Okay. All right, so exploratory data analysis techniques are particularly useful for detecting patterns in extreme data values. They are designed to help us explore a data set, ask questions we may not have thought to ask before, and pursue leads in many directions. Okay. They'll help us show relationships. I think you guys know I'm more of an example person, so I don't know. These are up on Canvas if you super want to read through this EDA stuff. Okay, so I don't know why they're just including this in this EDA aspect, but yes, if we create either a stem and leaf plot or a histogram or pretty much anything we can create, if you take a quick glance at it, you are going to be able to kind of find your outliers, see if everybody is more uniform, that kind of stuff will be kind of second nature to you once we get you going. Okay, in contrast, when we design an experiment to produce data to answer a specific question, we focus on particular aspects of the data that are useful to us. So the difference here is that when we create an experiment, you kind of already have a hypothesis in the back of your mind. So you don't just want to gather all evidence. Well, I should say most people, for some reason, don't gather all evidence. They try to just stick within their parameters so that then their data kind of supports their idea. A true researcher would want to collect everything and then see if their hypothesis would still hold true. Okay. Consequently, we do not explore our data as much, and we often make valid assumptions about the data. So I would sum up these 11 slides as telling you that from my more mathy side, you would want to do EDA analysis, because if you have a hypothesis and you only care about data regarding that hypothesis, proving it true or not, then you're going to kind of, you could potentially miss out on whole other aspects that you may not have thought of. And to me, I think that would just be a shame. So just keep that in the back of your mind. Okay. If you take handwritten notes, you want to write this stuff down. A stem and leaf display is a method of exploratory data analysis that is used to rank, order, and arrange data into groups. We know that frequency distributions and histograms provide a useful organization and summary of data. However, in a histogram, we lose most of the specific data values. So in a histogram, remember we talked about how it's kind of related to a bar graph. So you kind of just see that block, all right? And it tells you how many's there, but it doesn't actually show you each individual piece. With the stem and leaf display, you're actually going to be able to see each and every piece. A stem and leaf display is a device that organizes and groups data, but allows us to recover the original data if desired. In this next example, we will make a stem and leaf display. Okay. So this example is talking about airline passengers and their carry-on luggage. Just how much weight are they carrying? The carry-on luggage weights in pounds of a random sample of 40 passengers returning from vacation to Hawaii were recorded. So what we're going to do is we're going to create a stem and leaf plot that allows us to represent this data set in a little bit differently. So obviously, if you were going to do this and if we were in class, we would just go ahead and practice this. You don't have to practice it right this second. You can always come back and watch the video later and pause it here, or you can just practice it on your homework. You'll have plenty of practice. So to make a stem and leaf display, we break the digits of each data value into two parts. The left group of the digits is called a stem, and the remaining group of digits on the right is called the leaf. We are free to choose the number of digits to be included in the stem. The weights in our example consist of 2-digit numbers. For a 2-digit number, the stem collection is obviously the left digit. In our case, the tens digit will form the stems, and the units digits will form the leaves. For example, for 12, the stem is 1 and the leaf is 2. Have you guys have done this before? Yes, no, maybe? Okay.
I might know if I see it.
Okay. So when I was going through school, each algebra class we had, towards the end of the school year, we did do at least one chapter on stats. So if you've seen it before, then that's just going to be a little bit easier for you to do this. If you haven't, it's no big deal. I just didn't want to keep reading if you guys have seen it before. So this is how the stem and leaf works. You always have to have this little thing up at the top. That is your key, okay? You must always have a key for a stem and leaf plot, okay? If you don't give us the key, then it's basically just a bunch of numbers, and we can assume that this means, 3 or 0 or 12, but we don't really know. So if you don't give us this key, then we can't really figure out what you're doing. So the key is very important. You will miss points if you forget it. And notice here the difference between the two sets here is that on the left side, the leaves are not ordered, and on the right side, the final display, the leaves are ordered. You always want to turn it in the style on the right. You want to have that ordering from least to greatest on the right-hand side. And this stem and leaves part, you could write it in. You don't have to. I know that this bar means the stem's on the left and the leaves are on the right, okay? But if you choose to write it the other, with the wording, that's fine. All right, finally, we order the leaves as shown. From the stem and leaf display in figure 215, we can see that 2 bags weighed 27 pounds, 1 bag weighed 3 pounds, 1 bag weighed 51 pounds, and so on. We see the most weights are in the 30 range. Only 2 were less than 10 pounds and 6 were over 40. So if you come back here, 0 and 3, there is a formula we will use at some point to show if something is an outlier, but just kind of looking at that, the fact that somebody traveled without a carry-on, I would say pre-COVID, people traveling without carry-ons would be pretty rare. Nowadays, if someone's getting on, I can definitely foresee a lot of people not carrying stuff on and just kind of dealing with things. I don't know. I guess it would be interesting to run this analysis again with our current situation. And then 51, I don't really think I would consider 51 an outlier. If it said something crazy like 80 pounds, that would be pretty ridiculous. What kind of sucks for this person at 51 though is they definitely got dinged with that extra charge for 1 pound. So that kind of sucks. But all right. Note that the lengths of the lines containing the leaves would give the visual impression that a sideways histogram would present. As the final step, we indicate the scale. Again, that's your key. Okay, so if you need to write down the procedure, you can go ahead and take a few minutes and write that down. If you would prefer to do a screenshot, you can do that as well. Any questions on making a stem and leaf plot? Okay. Does anybody need more time with this slide? No? Okay. If you need it again, either just shoot me an email and I can send it to you, or it is up on Canvas and you'll also have it in the YouTube video. And is that the end? Yes, that is the end. Okay, so don't go anywhere yet. Can you guys see that? Yeah, cool. I'm gonna make it a bit bigger for my old eyes. So this is your exam 1 review guide. The language at the top is fairly consistent with what you will see on the actual exam as well. I recommend that you work everything out on separate paper. If you want to print this out, you certainly can. You'll notice as we continue throughout the course, the other exam guides are they don't really give you as much room. And that was because I didn't want you guys to have that much white space. I would work everything out on a separate sheet of paper. If you would like to print it out on here, you can. Like I said, if you're going to print it out, I would give yourself a little bit more room to work. And you can do that independently. Just if you only have the PDF version, which that might be the case on Canvas, shoot me an email and I'll send you the Word doc so that you can like adjust the spacing. Remember that you guys are allowed a note card. It can be large size front and back for your exam. If you don't have any large note cards, just shoot me an email. I'll approve the like basically a half a sheet of a regular piece of paper. We need to discuss when you guys will want to. I'm actually gonna also stop the recording.